What I'm going to talk about are the primary mechanisms, the primary allocation programs for the facility. I'll talk very briefly, about some of them and go in a little bit more detail about our primary allocation program called INCITE. But what I encourage you to do is to ask questions. I mean, mostly this is, the 25,000-foot sort of perspective on what these allocation programs are. So ask detailed questions, ask more pointed questions as we go through. My quick question, though, because it helps me target it, is how many people in the room have actually applied for an INCITE award before or know what that is anyway? Okay. Does anybody currently have one? All right, awesome, thank you. There's a couple of faces I think I recognize, so I just wanted to make sure. And so these are a set of slides. But in the end, right, I referenced something that I talked about this morning, which is that for the primary allocation programs, we are looking at awards that are in the 10 to 100 times what you're going to normally be looking at other facilities. The only allocatable resource going into 2020 is Theta, which you've already learned a great deal about. You're working on today. So I'm not going to walk through the hardware details about it. But what I wanted to point out is that is the only allocatable resource for next year. Often in this slide, if you've seen this slide before, and some of you probably have, Mira used to be on here. Mira was our Blue Gene Q, or is still our Blue Gene Q resource, and will be retired for the most part at the end of this calendar year. At least it'll be retired from the major allocation programs because we need that space for Aurora. So there'll be work and expansion going on in the space that it's currently occupying. So I particularly go down this route right now to point out that we've got one resource. It is not, say, the 200 petaflop Aurora that would have originally been on the floor today, but we've got a mission, right, of still delivering the 10 to 100 times the amount of computational capability to get out of the resources. So for the primary allocation programs going forward for 20 and 21, you can expect that there will not be many awards on Theta and that they will be big. Because we're not dealing with a particularly larger resource, we're going to probably be looking at particularly larger fractions of the machine that people need to use. The other thing, and mostly this is a placeholder, but I can perhaps not answer or evade questions particular, but for Aurora, there is a lot of information out there right now, especially if you Google it, you'll probably find more than I'm allowed to tell you, although there are some things I'm allowed to tell you. For example, that it's an Intel Cray-based machine, and it will have Intel XE technology in it. Google that. But it is not on the list of resources that, especially for INCITE, which I'll get into in a minute, that we're going to have, requestable at least for the next year or two. But it's something important to consider as you're thinking forward for your projects. It will be on the floor very soon. And so I tell this to people whenever we're looking at when a new resource will be hitting our floor, joining the facility. Even if it's not actually on the list for any of the programs right now, it will be very quickly. And so consider in the scale of what work you're doing that something that is 100 times more powerful that's on the floor right now will be coming in really short order, right? And the time frame where we develop how we do science and how we develop applications, that's like tomorrow, right? So this goes back again to what I said this morning. Keep your ear to the ground. We will be releasing as much information, even about application readiness, as we can. And we will be making that information as public and as accessible as possible. In the meantime, this is really going to focus on the allocation programs and how to use them and how to think about them, so you know how to map maybe where you are today, and sort of plan maybe your process, right? Your what you might target over the next 2 to 3 years. So there are kind of 3 categories of allocation programs. In the end, the primary ones are all the discretionary, the getting started projects. INCITE and ALCC, which are the big programmatic awards. I'll get into how these all break down. But then there are also targeted programs that we do that actually don't have an independent slice, say, of allocatable time on the machine, but like the data science program, the ADSP program, and the ESP is our early science program. And that's readiness for our next generation platforms. Those actually come straight out of our discretionary pool. But I'll talk a little bit about especially the data science program at the end of this, just to give you a sense, and also give you a sense of what it is, but also give you the heads up that it's just opened for its call for proposals as well. All right, so how this is broken down. So the time on Theta is broken down primarily into INCITE. INCITE gets 60% of all of the cycles on the machine. 20% goes to, and INCITE, sorry, I just plowing through that, is the open science, competitive, peer-reviewed process. 20% goes to ALCC. ALCC is the Department of Energy's Office of Science Strategic Program. So the Department of Energy makes the decisions specifically on who gets that time. It's normally mission-driven. It's not necessarily exclusively DOE-funded projects, but it is normally ones that align well with its mission, and it is often DOE-funded projects. And then 20% of the machine goes to serve the getting started process. Currently, these ratios have recently changed. And so if you saw this even last year, kind of depends on when you saw it last year, that breakdown actually would have been different. So it used to be 60% INCITE, 30% ALCC, and 10% discretionary. So the discretionary has grown because what we are currently serving out of that pool is the exascale computing program, and they have sort of a very diverse set of needs they need for their readiness. And so we're doing that collaboratively through our discretionary pool. But primarily, we use this discretionary pool for getting people ready for proposals. Now, sometimes people come in with a discretionary award and they need 3 months just to get their code on and do some quick scaling runs, and they're relatively ready to go. But sometimes that is a much longer 2-year process, right, where they know that they have a goal in mind, but they have got a lot of development or work to do before they get there. Probably not, no. The goal is that this will be pretty stable. The previous ratio, the 60-30-10, had been stable for years. For years. And the only reason this really shifted was as the exascale computing program demands were being figured out, like what do they need? There was ambiguity. Yeah, and so it took a while to sort of settle that and then come to this steady state. And actually, we're pretty sure this is going to stick around for at least the next couple of years. After the exascale computing program wraps up, this might adjust. But we actually have a lot of use for discretionary. Discretionary is often quite over-allocated, so we're going to push to probably keep this. You'll get a sense of the demands on it in a minute. All right. So for the discretionary, as I mentioned, right, primarily these are used for this getting started process, and it's everywhere from you need to do the very first steps on getting onto a supercomputer and understanding how to scale your application and sort of really doing those first stages to you're already pretty experienced. You just need to make sure you have the information ready for a proposal. The details, and you have these slides to download. So there's even a few slides in here that are primarily just like quick references, like the quick check mark, for right, what did she say about X, Y, or Z? The review process on this and the application process is meant to be very lightweight. It's meant to be very dexterous. So if you know that you have something really quick you just need to be able to do, you don't have to wait for a 6-month-long review process in order to get onto the machine. We try to get things turned around and in the 2-week time frame, excluding sort of things of getting paperwork for a foreign national to get on the machine, we can get you on pretty quickly and get you moving. The time ranges for these are really short, right? Sometimes they're as short as three months, right? If we're not even sure if the project is ready to do anything at all. Sometimes they're longer. 6 months tends to be the longest chunk. It does not mean that your project ends at that point. You can ask for more time, but it's meant to be sort of checkpoints. So as most of these projects are meant to be sort of development in process, getting proposal ready, we want to get a sense of what you're doing, making sure you're making progress, understanding, what kind of roadblocks you are hitting if you aren't making any progress. While it is 20%, it is a heavily burdened 20%. So this is sort of in contrast to the model I'm talking about for the big programs where we have very few projects. This has a lot of projects in it. So this 20% is heavily sliced between exascale computing, readiness, and some of our other programs like the data science program. So you don't tend to get huge allocations in this. You get sort of test and development scale applications in this, and it's really not targeted to doing production science. It might be targeted to the closest you might get to there is sort of doing benchmarks or test problems in order to demonstrate that for your INCITE proposal or an ALCC proposal. I can go fast. I actually sort of my biggest challenge when I talk is I start accelerating. So I'm, trying to make sure I don't talk too fast and make sure I notice if people have questions. So please ask questions, because it's sort of I can move into fire hose mode as we go forward. So in the end, the way the facility is built, we are built around the INCITE program. And we get, a lot of extra sponsor buy-in through the ALCC program. I'm going to walk through each of them separately. I'm going to talk a lot more in depth about INCITE, in part, right? It's representing 60% of the resource, and that's the primary reason. But the other reason is because we are the ones who manage INCITE. The ALCF and the OLCF together manage that program from start to finish. So we organize and run the call for proposals. We build the peer review teams. We do the computational readiness. We do all of that right into the final selection process. So in part, it is our goal with this is to be as transparent as possible, make it as clear as possible, everything that goes into the review process. And so this is the one that I really want to give people the best flavor for. And I will dive into any sort of deeper questions people have about what INCITE, what a particular part of the proposal needs to look like, or what you should worry about or not worry about. But I'll also point out that the ALCF staff who are in the room have also been doing this for years, right? So I've been part of INCITE since we started the program, but actually so have a great deal of ALCF staff. We've been doing this for years. So also, if you don't necessarily want to ask it during the talk, we are around. Ask us a targeted question or a more specific question for your problem as you need to. They're per year. So all the guidance you'll see in all the different tables is what is allocated on a per year basis. So even if you are requesting a 3-year proposal, so INCITE can be 1, 2, or 3 years, when we're giving you estimates about how much time people are asking for, it's how much they're asking for in each individual year. The comment, but I'll sort of riff off of that a little bit and say that multi-year proposals rarely have a flat profile. So there are some projects, right, that come in and say, I need a huge amount my first year and then a medium and a small, but they're rare. Mostly what it is building up, right? And you can sort of imagine why. You might be building for a particularly large campaign in your second or your third year. You might have in your third year both doing a new campaign and doing evaluation, doing analysis or visualization, or some sort of other work on a big campaign that you did. So most of them are actually building in request. Right. I'll get more into sort of the specific numbers in a little bit, but I think the two biggest things to remember about INCITE, and especially for INCITE for ALCF, is that we are looking at projects that will have many millions of I have to be careful by units. We are very recently, after my entire life of programming and thinking about in core hours, we're switching to node hours, and I was about to start talking in core hours. We're looking at few very large projects on Theta for 2019. I don't mean that to scare you away, but I mean that to encourage you to think very aggressively and to think, in a very large scale about what science you might be trying to accomplish. But the second one is that there's a 2-stage review process for INCITE. Even if we weren't allocating a very few number of projects for Theta and for OLCF, the premise is that most projects are pretty much ready to go on day 1 of their INCITE award. Does that mean they have everything lined up perfectly for all 3 years of an award? No, nobody expects that, right? But that there is work that they have proposed, milestones that they have proposed, that they're able to start making progress on day 1. So given that, the review process looks very carefully at the impact of the science work, the proposed sort of path for the science work, and that's what the peer review panelists are looking at. But it also looks at your readiness. It also looks at, so where is the application base, the code base that you're using? Has it already been demonstrated on the resource? Has it already been demonstrated at the scale you plan to use it on? And actually with the science problem, at least some version of the science problem that you want to test. And it's looking at those in pretty good detail so that we understand at least what kinds of challenges you're likely to run into. And this is, that we try to capture basically as much as we can those projects that can go gangbusters day 1 to those which will need, maybe some help going forward. But we're looking at both of those criteria. Yeah. Yep. So the question was, can you talk a little bit about the science problem, right? Like what kind of, is it sort of what kind of science are people generally proposing, or what's an acceptable science problem to propose? Right.
Success.
So
in getting it.
Right. So what's the highest probability of success, sort of, and what kind of science you're going to propose? And you're not going to love the answer, right? But the way that INCITE was designed was that if you're giving 10, maybe 20 projects, such a large fraction of the resource, you want a very high impact result from that. That result can be you're solving a question, right, that has been plaguing your community for a while. You're providing a data set that people have been striving for a long time, or in some cases don't even realize quite that they need yet, and you're serving an actual, a need looking forward. It can sort of any combination of those, right? So the premise is you're doing something that has this chance of changing the way your field operates or answering these long-term questions. Correlated with that, though, is I think the most crucial part, flat out, right, of the proposal process, which is proving that to your peer panel, right? Proving that the problem is very important and that you know how to get there. So what I mean by that is that in the peer panel, you will have experts in your area, to a degree, reading your proposal. So what I mean by to a degree is that you might not, we have a challenge, right? Because people who do large-scale computing in a particular particular domain of science or engineering, no matter what field it is, it tends to be not that many people. So we have, a lot of games to play and chess pieces to play about managing conflicts with that. So you tend to have somebody who knows your field very well, who is maybe working in, or has worked, right, in your specific subdomain really well, reading your proposal and actually doing the formal review. But the full peer panel reads that. So it might be that you are in a materials panel specifically looking at, sort of particularly small-scale structure, right? That's the whole panel just looking at that subsection of material science. The whole panel will discuss your proposal. And so one thing I'll recommend is thinking about in that science narrative that you're putting together and thinking about the big question is really making sure that you're playing that game of speaking both to the more specific expert, but also making sure that the other people, say, I'm just using material science as an example, the other people in material science who aren't as locked into your domain buy your story. And that's actually a pretty big one that I think people sometimes forget, right? Especially when you compare it to writing a paper, right, where you tend to have 3 or 4 people who, you might even be connected to, in some way, shape, or form. You might still be connected to the specific reviewers, but the larger panel might not know your work as well. So you have to sort of make those connections for them. That didn't really quite answer your question, right? And I acknowledge that. Excellent, awesome. So this is actually, this is why I switched to the slide and I left it on that after you asked the question, right? Because this is really the point of INCITE, is looking for these transformational problems, looking for something that people didn't think they could do before, or for the first time we can now do it, right? We often see, especially the holy crow, we can actually solve this problem now. Really big transitions happening, let's say, when we put down new machines, right? And suddenly there's this influx of, we could never afford to even entertain quantum Monte Carlo before, but hey, now we can. Right, and so let's target our problem, that way. We can do something completely new, a new approach. I talked about the criteria a little bit, and so that you have both the peer review and the computational readiness. What I did not comment on, and I hope as scientists and engineers this will be clear, the most important part is number 1, is your merit criterion in your science or engineering space. The way I describe this to people is you can be as ready as anybody could possibly be, but if you do not do well in the science and engineering evaluation, you probably will not get an award. In contrast, right, if you're one of the highest ranked proposals in a science or engineering space and your readiness is not at the absolute top mark, we might still be talking about how can we entertain that proposal because it was top ranked, right? And we want to be able to sort of move that science forward. What can we do to make sure that they're maybe successful next year or accelerate them into their readiness? So number 1 is really number 1. It's not just there for numbering schemes. It's the top priority. But then we will, as I said, we will look based on your peer review, look at the most ready proposals within that area. I will say that this kind of comes up in a few different other venues. There are webinars that INCITE runs every year that go in depth on all the sections of the proposal. I highly recommend them. We've been iterating on this for several years, but the proposal process does change, right? We're evolving a little bit the proposal every single year, not to play tricks on anybody, but to try to make it actually get the information we need better, but also serve the science and engineering community, which is sort of changing even some of the ways that they do work. So the different components of both 1 and 2, we try to walk you through those very clearly, describe each section, give examples of what we need, give you sample proposals that you can sort of look at and try to sort of match to what you're trying to accomplish. The other thing is the people often ask about eligibility. I'll just finish this and then absolutely, is that the short version of this is anyone is eligible to apply. You do not have to have DOE funding. You do not have to have US-based funding. So we have a pretty reasonably sized, anyway, international set of proposals every year. The only criteria or restriction we often run into is if you have foreign nationals who are not allowed on the system. And so, for example, citizens of countries that are listed as sponsors of terrorism, we cannot get on the machine. So that actually has run into problems historically and slowed down projects anyway. Yes, what's the question? That's a great question. I love it. So I'm just going to skip forward. So actually, I'll go straight to it, and then because we can go back. There's no hard reason for why the orders are in that particular direction. So there's a few different ways to break down the information you're leaving. In the end, the acceptance rate historically is about 30% for new proposals. That kind of goes up and down. So last year, this went up a little bit because Oak Ridge had both Titan and Summit on the floor. They will only have Summit on the floor next year. And also with Summit on the floor, they sort of accepted, as a brand new machine, they accepted more proposals than they want to necessarily do historically. So there's a little bit of an uptick in this for this past year, for the 2019 is that year. So just the past allocation process for this calendar year. But I think if you work with about 30% in your mind, that's about right. And that's been pretty consistent. So with 104 new proposals last year, which is relatively modest compared to sort of some years, even when we were up to 150, 160, it was still about 30%. The difference is that we have seen a continual decrease in the total number of projects that we allocate. In part, we attribute this to, and when we see evidence of this, that, say, when INCITE started 10, 15 years ago, the primary people competing for that time was relatively predictable. They were all doing sort of large science campaigns from fields that, had been doing large science campaigns for a long time. So they had a lot of history of doing it, and other fields were building up, other sub areas were building up to sort of build up to that capability. We've seen a great growth, right, in the total number of domains, the total number of types of projects that are competing at this scale. And so the diversity has grown substantially. The other one, though, that I will point out, and I kind of skipped over it in part because of order, is that renewals for INCITE. So as I mentioned, INCITE is a 1, 2, or 3 year program. 1 year is challenging, right? 1 year is you have been using, say, the facility for a while. You already know your problem runs, and you have a single shot thing that you need to get done because a year goes by really quickly, really, really quickly. So I thought that I'd dissuade people from doing it. A lot of people propose this. Some people kind of are chronic 1 year proposers. So they go through the full review process every year. And if that's what you prefer, do it. But that's kind of the mindset, right, with 1 year is it's sort of a one-shot major thing, and then you have to be done because the proposal, right, is just going to be for that 1 year and looking at the scope of that single year. But for 2 or 3 year proposals, it is not a full review process every single year. The assumption in INCITE is that you have gone through the scientific peer review, the most challenging, the most competitive part. And we have decided to make an investment in you as a project, right? So our hope is that you succeed. The review process for INCITE is not necessarily a rubber stamp. We make sure that you are on your, but it is much easier. That's what I meant to say. It is It is, one, a check that you are still on track with the milestones you originally proposed, and that's sort of double checking that, you know, you propose something that people believed in, right? They're like, all right, we believe you can actually execute this, and we believe in the steps, right, that you proposed. So, all right, are you actually making progress on those milestones? If you haven't, why not? You know, if you've blown past them, great. Tell us something that interesting that happened out of that. And then basically just a quick assessment of whether you're still on scope, right? So I don't mean to dismiss it, but that on scope part is really important. So we do have projects, as kind of happens, right? You start exploring or trying to figure out the answer to a question, and an entirely other, more compelling question comes up in the process. So we have had projects that in the renewal process say, yeah, I know I proposed this question, but I'm actually asking this question now because it's more compelling. If they actually bring that to us, we actually, before they submit their renewal, we sometimes suggest they submit a new proposal. Because in the end, if you're talking about something that's so removed from your original plan, it's often quite confusing for reviewers. They're like, they're trying to, they proposed question A, they're looking at question B, they're not super overlapped, so I don't know how to evaluate this anymore, right? I don't know how to sort of put this in the category of yes, they should keep going or no, because I don't have all the information for what they're going to do to answer question B. But really, it's that staying on scope part that's relevant for renewals. So the renewals have a very high renewal rate. The most common reason a renewal is not renewed is because that jump off of scope, right? Is like for whatever reason, right? I'm either now asking this question for good reasons or bad reasons, it doesn't matter, but I'm very, very removed from what I originally proposed. And this happens normally once or twice a year, although I think last year was at 100% for renewals. The other component to this is that the renewals also submit those renewals a little bit later in the calendar year. And the reason is the following. So if people have looked at the INCITE proposal timeline, right, you're submitting that at the end of June for a new proposal. If you were a new INCITE project that started in January and you had to submit your renewal in June, that's not a lot of time. We're committed that an INCITE project, for example, will be able to get on the machine before even their allocation starts, right? And you'll be able to sort of get things lined up, but still 6 months is really not a lot of time. So we give you as much time as possible. It's normally closer to the August timeframe to at least get a little bit further along in your first year progress. And so rather than make life complicated, all renewals submit in that later timeframe for the year. I'm going to hop back for a second. This you can have as reference, right, especially as you're thinking about your proposal. This is just the breakdown in the proposal assessments. I've mentioned all of these points by this point, except I will say that one of the things that they are also looking for, besides sort of the scope of the question, right, the scope of the impact of your work, is do you have the people ready to go, right? So one of the other biggest challenges with these campaigns is they can be people intensive, right? So and I did this for a very long time, right? I have like whole months of my life that are blacked out just running things and managing running a campaign. So they want to make sure that you have both the right scientific expertise and the right people with boots on the ground, right, to be able to execute the campaign you're proposing. And so they will be looking for that. It is not this huge fraction of your proposal, but just keep an eye, keep your eye open for that. And the other thing, and this is related to the computational readiness, and this is one of the reasons to have this workshop, right, is preparing your estimate for the total time that you'll need. So there's two aspects of this. In the computational readiness, people will look and say, all right, you want to propose a problem that does this many simulations and that you think each simulation costs this much, and they'll look to see how you did that calculation, right? You did some benchmarks. The benchmarks relate to my problem this way, and just follow the math up. The other thing, though, that the peer panel will look at is say, here's this question they're proposing. And the answer to that, right, is it worth 10% of the machine, right? Is it that valuable of a question today? Or do we feel like they are not solving their problem very effectively? There might be other techniques they could do that would do this in a less expensive manner. But in contrast to that, they might say, we don't care if they could do this in a less expensive manner. We need the answer for this field tomorrow. And so, yes, we can make this happen. It kind of doesn't matter how expensive it is. We need that answer tomorrow. But that kind of question, right, is really going on in that evaluation of the reasonableness of the requested resource. My last example, though, of, oh, my goodness, this question is so important to get answered. We don't care how much time it takes. I recommend you don't bank on that or bet on that in the review process, and try to give the best estimate on that you can in the time. All right. The other thing I'll comment on for INCITE are some recent changes. So I mentioned that the actual proposal form does not stay the same every single year. In part, this is us trying to improve our guidance to you and improve the material that ends up getting to the peer panels, right? And so this is sort of a constant small iteration. But one of the other things is that the way that most of the scientists on our platforms are trying to execute their science is not the same today as it was 10 years ago, right? So the number of proposals we got last year, it was actually almost 15% of the proposals last year had a machine learning component as a note. Now, it wasn't necessarily that they were big, giant machine learning problems, but it might have been a problem that was using machine learning in a particular subcomponent of their algorithm, right? All the way up to sort of big machine learning type proposals. So that's one example. We also have sort of a lot more data-driven problems that are competing in INCITE, right? And in part, that's because of our ability to generate data is so rapid right now that people are coming in and saying, I do need to generate a petabyte a minute, right? Can you help me parse that petabyte a minute and make that a manageable sum? So those have at least traditionally been thought of as very different requirements than traditional simulation. And in terms of computationally, actually it's not super different in terms of requirements out of the system, but in terms of what questions we ask in the proposal, they are slightly different, right? And we've been trying to adjust the INCITE proposal process, right, to make sure to address these, to capture that, to give sort of the right even frame of reference for the reviewers that these different types of problems are as welcome in this program as the traditional simulation program. Well, and it kind of depends on the nature of the problem, right? So like a learning problem where you have, you only have to worry about getting, I'm making up numbers completely, like, 1,000 problems through a week, right, in order to give you a rate of time to solution that works for you. That's one thing. What really drives, and high throughput can also be in this category of valid uses of INCITE, is if what's really important is that you get your answer in 5 minutes, right? So this is an example like with a lot of data streaming problems or coupling with experiments, right? What's really important is that they have 5,000 nodes that they can use right now and get an answer 5 minutes from now and use that answer effectively. So that is a perfectly reasonable example in a big driver. If they have to do that once in a year, then no, we're just going to take them into discretionary and help them out and do it that way, right? But if they have to do that for basically a month for a month of a year, like 1 month period in the year, this is a totally reasonable INCITE program, a proposal. And sort of the same thing in the learning. The data one is, I think, a very straightforward example. But in the end, if you can demonstrate that this is something that you have to do in a large-scale system for some aspect of time to solution, then you can make the case normally. And for the high throughput, actually, this is one that we've had at least more historically present in INCITE. It took a while. It was oscillating, right, of back and forth and sort of figuring out how to give people the right guidance. But we have high throughput problems, basically, in INCITE today. And sort of the canonical way we describe it is what changes in answering your question, right? When you can get the answer to your question, in a day or a week versus waiting 6 months, are you able to do something better with that, right? And so we've had people propose really innovative ways of workflow and investigation, right, as a result of changing that way of running their projects. So, but I do caution, right, that if you're proposing a very small project without that sort of sense of motivation of why the time to solution or why the access to sort of a large-scale resource isn't clear, that tends to send up flags of just trying to figure out why. So, right. But I would say that we're seeing some of this going forward. Some of these changes to the proposal process going forward. And keep your eye open, even if you've done this before, to sort of look at what's sort of evolving in there. And I want to actually speak to this one particular point up here because I think it's important, right? So one of the ways we're trying to tackle sort of the diversity of requirements in some of these proposals is, for example, what we did last year. Last year was the first year that what we did was have proposals that had a substantial learning component evaluated by a panel of people who are experts in machine learning. So if you were a biology proposal, you'd still be reviewed by the biology peer panel and still evaluated against other biology proposals, but your use of machine learning was also evaluated. So is this a reasonable application? Do they know what they're doing? Have they actually formulated, right, the question that they're asking and what they need, to put into the machine learning that they're using and get out of it? That kind of question was being asked in the machine learning panel. And to give you a quick sense of numbers, the most relevant one, right, today for us is the last column. So in 2019, we allocated 16 projects on Theta. If you start doing math on these, I'll just say that there's a lot of overlapping projects, like projects that had out time on Theta and Mira and Summit, or things like this, right? So the total INCITE projects don't sum to the top, isn't the sum of the top row. It is a subset. It's an overlapping diagram. But it was 16 projects on Theta. Be the same amount of time in 2020. We expect that number will not go up in terms of total number of projects. We expect it will probably actually decrease. Okay, my other last bit, and then you can get to at least relax for a few minutes, is I wanted to touch on the ALCC program. This, as I said, is mission-driven for the Department of Energy. They do a peer review. It is not as transparent, right? They're normally collecting some experts to do a review. How many? They try to at least do 3, but it's not a guarantee, especially if you've got a particular sort of niche proposal that they're going through. That call is in February. That call closes, I should say, in February. And the year for ALCC is just offset from INCITE by 6 months. It just kind of makes some of the logistics of managing the way people use their allocations a little bit easier. Because you can imagine there are down periods in using allocation. People are not as excited about using their allocation in the first 2 weeks of your allocation period. They're much more excited about it in the last 2 weeks of their allocation period. So having these 2 programs offset by 6 months helps a little bit with that. What I would say is if you are considering an ALCC proposal, you have some connection to Office of Science, perhaps you have your program manager, go talk to your program manager, poke your program manager, and start talking with them, because what I will say, what is transparent to us anyway with this is that when they're making the final assessments for ALCC, what they are doing is going to the different program offices in the Office of Science and going, what do you care about? What do you want to get done? And so if your program manager can speak up for you and put that stake down, it will help. It will help a lot. So this is just your quick reference. I'm not going to walk through that. Most of the stuff has been talked to already. Your quick reference for what the programs are and sort of, what the basic numbers sort of look like for each of the individual programs. What I didn't say about ALCC, actually, and I will comment on this, is the total number of projects really varies dramatically in ALCC. So some years, the Office of Science, gives us 5. Some years, they give us 20. So the total amount is quite variable. They tend to not be as rigorous with the computational readiness, because what they want to do is just get work done, right? They're looking at a scientific problem that has some importance to them, and they want to make sure it gets the computational time to actually be executed. So, I mean, there's some readiness, but it isn't quite as aggressive as the INCITE computational readiness component. The last one I will comment on, and you can also find more information on the website. You can also talk to Venkat, who is here today, although he's not in the room at this exact moment, is that we started a few years ago a data science program. So it's the Argonne Data Science Program. That's what the letters stand for. Not very wild or crazy. The call for that is also open right now. This is a small program, and I wanted to talk to it to give you a sense of why we're running it, why we started it. Since we started it, most of the other computing facilities also created one. But this goes back to the fact that if you look at what comes in through INCITE today, if you look at what scientists are proposing for what they want to do 3 or 4 years from now, it really doesn't look like I want to run a big campaign and be done and go take my data and go away, right? normally some complex workflow associated with what they want to do. Even if it is, I want to run a big campaign, they might be doing a lot of in situ analysis, or they might be doing a lot of post-processing and trying to feed that into smaller snippets, whatever, right? It's a much more complicated, more dynamic way of doing computational science than we saw several years ago. And what we wanted to do with this program was start getting some test cases, some people who were willing to collaborate with us, who had some challenges, some scientific challenges they wanted to tackle that needed to sort of explore both technically how they would do that and then move that science forward. So the ADSP program is really meant to sort of, one, we will give you time to help you solve this interesting problem if you work with us on helping to figure out what the demands are of your technical parts of your problem, so we understand how to improve how the facility design is, what the facility design is moving forward. We change the facility design, right? It's not like some hard set thing. As we acquire new machines, we think about very different balances for different components of the hardware. We think about different balance for how we're getting data into the facility or how much we're putting on storage. I mean, in the end, there's still a budget number, and we're still constrained by that. But we wanted some collaborations to actually drive part of those decisions, where we're digging in deep with some of the scientists on what they were trying to accomplish. And so that's what the data science program is. There's normally only 2 to 4 projects that we award a year. Maybe 1 to 2 of those will be given time of a postdoc, but then there'll be staff time, as I said, as we collaborate with them and try to figure out what they need, move their technical problems forward, and execute their problems. There's other slides in here that you can use as reference, but that's primarily what I wanted to cover. Any questions? Oh, that's a complicated one. So what we have is a very frequent rate of projects that move back and forth for a handful of different reasons, right? So some of those reasons are no longer as necessary, right? We used to have projects that would be in INCITE. They would transition to ALCC because maybe it was just slightly less onerous to get that time to do some analysis, and then they'd go back and compete in INCITE. On the analysis side, that has sort of gone away, as it's a completely reasonable thing to fold into your INCITE awards. I just want to make sure that's clear. I would say in the end, we see 3 or 4 projects every year doing some part of that. And sometimes it's projects that aren't successful in INCITE, and they go and they compete and petition for the time for ALCC. But it's those 3 to 4 projects are not consistent every year. There are a few players who we see kind of repeat that behavior. It's not a bad behavior, but normally it's actually pretty dynamic in who's doing it. So I'll repeat it, and I have a couple comments that are meant to be very general comments. So his observation was that his larger collaboration had submitted 2 different proposals 1 year after another, asking for a 3-year award, and instead being awarded 1 year. And that happens, especially that can happen in 1 year, but have that repeated the second year. And I can imagine the frustration. I'm familiar with the proposal. So trying to make a couple very general comments and trying to make a point to generalize them. This can happen. So what we ask out of the peer panels is more complicated than yes or no. We ask out of the peer panels, well, all right, if you had let's say they're thinking about a proposal as sort of mid-level, and they have had to put it mid-level, or like in sort of comparing and ranking across all the proposals they're looking at. They've had to put it mid-level because they like one part, but they don't like the other part. What we will ask the peer panel to tell us is, if there is a particular problem that we really should fund, but do not fund this one. And given that guidance, right, fund this part, but don't fund this one because we have our concerns about it. And those concerns can be a handful of different things. And I can explain what some of those might be. Then your proposal might move higher up on sort of the ranking of the best proposals in the panel. Things that often drive a panel to sort of ask that question is maybe they're not convinced the other part that they have concerned about is ready. And that can be both ready in terms of perhaps expertise. It can be ready in terms of methods. It can even be ready in terms of the total amount of time it needs, right? So I'll get into a second part of that in a second. But it can also be that they think one part is a really much more exciting question to answer than the second part.
And if you've got, so that's sort of one way to break that down. So if they think the second part isn't that exciting and maybe not worth as much time as the first part, they'll say, do the first part. We're super excited about that, and then move forward. In a similar vein, they could say that we're not completely convinced this proposal is ready to go. We think it's really important, and if they're able to be successful, if they're able to do part one, wow, awesome, right? But we don't know for sure. We want them to try and come back in the second year and recompete. Like, let's see what you look like next year. The peer review panels have a pretty major overlap from one year to the other. There are people who go and come, right? But for the most part, our repeat reviewers are pretty high. It's in the 60 to 70% range. They last, about 3 years. We tend to not to ask that much more of them. If somebody's really excited, there have been a few reviewers who come back who are really good and really enjoy it, but we tend to not exhaust them. So we don't keep asking year after year after year. So anyway, that same panel will be able to look at the proposal next year and do an assessment. So that's a type of feedback. This meant to be very general. I just want to make sure this is clear because none of those are very specific to that one. There was a thing I was going to go back and touch on, and I apologize because I just blanked on it. Right. So one of the components also that makes things tricky for the peer panel is what we call umbrella proposals. And I'll unwind what that means because a lot of people call things different things. So an umbrella proposal is a proposal where you might have 10 or 15 different projects that are not all necessarily the same project, that are not necessarily coupled in any way, but they might be all under, subdomain A. And by piecing those together, you have made a proposal that is of an INCITE award scale. The challenge with these proposals is they're all very different. They're not correlated. They're not integrated in sort of answering sort of a larger motivating question. It's really hard for the peer panelists to review it. And I bring this up second to my previous point because it's easy when it's part one and part two, and saying part one's really good and part two isn't, so let's focus on part one. It's really hard if it's 15 parts, right? The proposal length is limited, right? We don't want people submitting 100-page proposals because we can't read 150, 100-page proposals. And so if you've got 15 different components, the amount of time you're able to put into the narrative and motivate each problem gets really hard, right? You've only now 2 paragraphs per problem effectively, right? So that review process is hard to do. And so most most peer panels, when they're looking at them, go, I get that these might be really compelling problems, and I actually believe that they might be individual problems, but I don't have enough information to rank it well against these other proposals where I have a great deal of information and I know exactly what they're going to do to get there. This is not to say that umbrella proposals can't be successful, but it's a big uphill climb. We have not figured out the right magic, right? That doesn't result in a 100-page proposal. That gives the peer reviewers the right information that they need and to be able to do a really effective comparative peer review against everything that they're looking at in their portfolio. So those are. I appreciate you bringing it up because I think it's a really challenging one on our side and on the science side, right? We get it. Every year we're sort of trying to figure out a better way to move it forward. Yeah. I will say that what we can disclose is that Aurora is going to be an Intel XE technology, and Google is your friend. This is not quite where you're going, but I will say that it's sort of entertaining, right? That you can say more than I can, right? If you Google these things, you can say more about what Aurora might look like than I can, and it's because I know what Aurora will look like, and people will come after me with facts. Lawyers will come after me with facts, and then vendors will come after me with facts. We will disclose more details about this. It will escalate very quickly over the course of the next year. That was not your question. So his question, which was a really good one, was that proposals going to Oak Ridge are reviewed aggressively for whether they are using the GPUs on Summit and whether they are using them effectively. Effectively has an ambiguous definition, though, I will say. So but it is still whether you are using them effectively. So they really do want to see not that you get, a 1.5x improvement if you're using the GPUs, you get something really substantial. We have, and so given that I cannot talk about the details there on Aurora, I will say that we have an obligation to make sure that the machines are well used. Oak Ridge does and Argonne does. So if we're putting down a technology that relies on a particular piece of hardware for a large fraction of its performance, we have to make sure that projects use it, right? That we aren't, say, deploying an exascale system, but people are only using one part of the system that might be, 20 petaflops or something akin to that, right? The DOE, I think, would quite reasonably raise its hand and go, what the heck, right? What are we paying for? So there's a handful of ways that we deal with this. One of them is that we are very focused on how we're going to get projects ready for Aurora. I actually have a lot of confidence in the path we have today, and that it might bring a little bit better cohesiveness in the programming model for at least the Department of Energy programming environment and scientific computing. But that is really what our primary energy will be focused on for the next couple of years. And making sure that as that machine is deployed, we are using it effectively. We'll also point out that there's always ramp-up time, right? So the reason we have an early science program, which I just kind of skipped over in these slides, but we have an early science program, which is completely focused on taking members of the community. There are 15 official projects, another 5, so 20 projects that we're collaborating with, plus ECP projects, understanding how they're going to use Aurora. And the reason we do that isn't just to say to those projects, yay, go have fun, right, and now you're ready, nobody else is. The reason we do that is actually to extract best practices. So we understand, say, looking at these 3 different engineering problems, what type of fluid dynamics problems, what type of approaches to the fluid dynamics applications, using finite element, right? What did they have to do to exploit it, and sort of pull those best practices out. That's not to necessarily say that will make work easy for everybody, but it does mean that suddenly we learn a lot too, and that can really accelerate our ability to collaborate and move an application into readiness for Aurora. I hope that wasn't too much of a tap dance. So what I will say is that at least with accelerator technology, it's not unknown, right? So frankly, right, Oak Ridge had a pretty hard lift several years ago when they put their first accelerator-based machine on the floor, right? Scientific applications didn't. We're not messing with that at that point, right? And that's that was an interesting and really hard challenge for them. I would say that the scientific community and the methods community is only just now, I think, gaining a little bit of good speed and good direction with how to use accelerators effectively for scientific computing. Some people already have it down nailed, right? I'm not saying that everybody's figuring it out, but I think in the larger community, we're getting it. Other questions? I will say on the Aurora side, and on concerns you have about readiness, there are concerns too. I promise you. and that's, as I said, that's what we're going to be focused on for the next 2 years. And if you keep your ears out, we will try to be making sure it's blatantly in your face, right? But also keep your ears open, right? And your eyes open, sorry, and keep listening, and you will not miss, I hope, the information we're able to disclose and the guidance we'll give to applications. There's also already some of that out there, but I didn't quite prepare for this. But I will say stick to open programming models. Don't adopt proprietary programming models. That's actually my biggest piece of advice. Do not adopt proprietary programming models for your scientific application. And that's a general piece of advice, but I think it's a particularly good one looking forward to the Department of Energy.